Welcome guys. So in this video, in a series video, I will first introduce the Hermite polynomial and prove the basic property, and after that we can go to the quantum mechanics and the simple harmonic oscillator. So let's quickly review the Hermite polynomial. So this is the generating function definition. We start from this gxt defined to be exponential minus t squared plus 2xt, and defined as an expansion of this hn. So that's I say that hn is hn of x. Okay, so the first two is the recursion formula, right? So hn plus 1 is 2x, hn minus 2n, hn minus 1, hn prime is 2n, hn minus 1. So to prove it, we first do this partial g partial t, right? So we get minus 2t plus 2x. This one equals to 0 to infinity hn plus 1 tn factorial. Basically, if you do the differentiation, right, you will lose 1n, so lose 1 factor of t. So put here, and then you put you expand this one, right? So you get this one plus this one. Then you compare these three, right? You compare these three, then you get the first one. Okay, the next one is hn prime equals to 2n times hn minus 1. We just do the differentiation respect to x, right? So we get the same thing, but plus 2t, right? So 2t times it becomes this, and by definition this is this one. So we get this hn prime equals to 2n hn minus 1, 2n hn minus 1. Sorry, should be plus sign here. Okay. Okay, let's say a special value. So special value is like a Legendre polynomial, right? So in the previous lecture, we proved that Legendre polynomial has Pn1 is 1, Pn minus 1 is negative to the power n. Same things we will do in the Hermite polynomial. So we just take x equals to 0, right? So remember when x equals 0, then we get the exponential negative t squared. So we have this, right? Equals to n equals to 0 goes to infinity. So compare these two, then we can get the so this exponential negative t squared only has the even power, right? So h2n plus 1 0 is 0, h2n 0 is minus 1 to n factorial divided by n factorial. Okay, and the final things, I think it's very easy, just the parity. So remember in the Legendre polynomial, right, we have this one. That should be negative x, right? So in the Legendre polynomial is even function when n is even, is odd function when n is odd. Okay. So for parity, we just change xt to negative x, negative t. So this generating function is still the same, and x to negative x minus t to n, and from 0 to infinity. So compare these two, then we get hn negative x equals to minus n to hn. So this is exactly the same as Legendre, which just tell you that the hn is even. If n is even, if hn is odd, then the n is if hn is even, then it's even. If n is odd, then it's odd. Okay. I think that's the first video about Legendre. The Hermite polynomial. In the next video, we will give the orthogonality and the other alternative representation, and I will see you guys in the next videos.